Hello. The purpose of this video is to present the paper titled Social Network Analysis for Business Process Discovery. The paper starts with a general introduction of the topic, followed by a small literature review regarding process mining and social network analysis. Later, the new approach is proposed, including its planned implementation in the process mining application PROM or PRO-M. Also, the authors are testing their proposal within a case study and finally presents the conclusions and references. So, process mining arises as a powerful technique for analyzing event logs produced by process-aware information systems such as ERP and CRM systems. It can provide important knowledge to improve the execution of processes and the quality of organizations' services. Researches in process mining can be classified according to two dimensions: process mining perspective and process mining aspects. Process mining research perspective has three elements: process perspective, which focuses on the ordering of business process activities. Organizational perspective focuses on performers involved in the process model. And case perspective focuses on the properties of the case. On the other hand, process mining research aspects are discovery, which generates new model based on the event logs information. Just summarizing what was actually done. Conformity checking that exposes the differences between some a priori model and real process model constructed based on event logs. And finally, extension, wherein a prior model is enriched and extended with new aspects and perspectives of the event log. This work focuses on discovery aspects within the organizational perspective. So, event log is a set of events. Each event in the log is linked to a particular trace or case and refers to an activity that can have several properties associated, like timestamp, activity name, activity type, resource or performer. So for example, in this table, the first trace is composed by 4 events, 1A, 1B, 1C, and 1D, with different properties. Driving social network or establish relationship among individuals from event log could be done based on possible causality, like handover of work or subcontracting, joint cases, like working together algorithm, joint activity, which focuses on the activities performed by individuals, or special events consider the type of the event. The PROM framework is an open source tool that includes plugins to apply all processes or process mining perspectives and aspects in one place. It receives event logs in XML format, which stands for mining XML. It is a specific format from XML designed for PRO-M. The most commonly matrices used at individual level are degree between centrality, closeness centrality, eigenvector centrality, clustering coefficient. Also, there are measures for like the network level, like density, clustering coefficient, and centralization. For the network level used to make some conclusions about the entire network to determine the capacity of the network to be separated in smaller subnetworks or clusters. Nodes usually appear in distinct community structures. A community is defined as a set of nodes densely connected with one another. Nodes that belong to the same group have a high level of similarity. Different communities are linked by sparse connections. Traditional approaches to find communities are graph partitioning and hierarchical algorithms. The disadvantages of them are algorithms do not provide any hint about how many communities a network should be split into, or number of clusters. To address this problem, a concept of modularity has emerged. It is a quality measure for graph clustering, which measures if a specific division of a network into a group of communities is good or not, in the sense that the connections inside the community are dense and the connections between communities are sparse. The available tools are poor in terms of data representation. So it's very challenging for the user to analyze and explore sociograms. Algorithms are only able to map the relationship between two individuals, but it cannot map the relationship among communities or teams. The main goal of this work is to develop new technology to identify communities in networks. Also, simplify the representation and visualization techniques that can show a progressive formulation of the communities. Finally, to be able to implement those techniques as a plugin in ProM. The algorithm proposed is a merge of two already known concepts: hierarchical agglomerative clustering and modularity, in the following steps. First, assign each node to a cluster where cluster containing just one node. Merge the two clusters with the most powerful relationship. Compute distance between the new cluster and each of the old clusters using one of the following methods: link linkage, complete linkage, average linkage. Determine the value of modularity for this number of clusters. Then repeat steps number 2, 3, 4 until all nodes fit in one cluster. This algorithm allows to analyze the network at the individual level and also allow to analyze the network at the organizational level, while identifying communities and showing the relationship between those communities. The case study domain was the emergency department of Hospital South Sebastian, where the focus was to analyze how people from the emergency department work together. Through analyzing the formation of communities formed in the department using log files containing business process in the duration of 12 days. During the period of 12 days, the log has stored all steps of the 231 originator user. This figure is the result of the first iteration of the proposed algorithm using working together technique, where no attempt of clustering has been made. Because in this step, each originator is attributed to a single cluster. Since we are using working together technique, it means that nodes are users and the edges exist if those two users were working together on any of the processes. The algorithm computes the value of modularity for all iterations. So each iteration gives a specific set of organization units, and modularity is used to determine if this set is the best scenario possible. In this case study, the best iteration was iteration number 180. Here we can analyze the relationship among the communities. Also, the plugin allows the user to zoom into any community in order to analyze the relationship among all originators who compose that specific community. After applying the proposed algorithm using working together technique, it was observed the following. Nurses rarely work with each other, unless in case of handover. The same for imaging or scan specialists. There are at least a doctor and a nurse exist inside each group. Doctors have more tendency to work in groups. Emergency doctors are always in the center of the network, playing a very important role. Other specialists only participate in the business process in two specific cases. First, if nurse determine from the beginning that the patient will need a specific treatment, or when the patient case assessed by emergency doctor and decided that the case requires special treatment from another specialist. As a conclusion, the complexity and large dimensions of the event log from the hospital helped testing the behavior and performance of the plugin. When analyzing sociogram with more than 400 nodes, it was noticed that the analysis turned more difficult, no matter how powerful the tool is. In order to overcome this issue, a decision to support graphical visualization with the matrix displaying all the relationship among nodes or communities was implemented. Also, the work were able to prove the modularity concept fully works and the algorithm discovers communities correctly. The study has not only driven conclusions about who work with whom and who perform similar tasks, but also helped to drive the business process of the emergency department. Here we have a list of references used in the study. Yeah, and that's all. Thank you.